My dear JEE warriors, welcome to the class 11th chapter of motion in a straight line, where we are going to talk about distance, displacement, speed, velocity, acceleration, the kinematic equations, and how to apply them in problem solving. We'll obviously conduct a separate class for motion under gravity, projectile motion separate, and of course non-uniform motion where graphs, derivatives, slopes, integration, areas, etc. are involved. In case you have not yet checked the basics of kinematics or the basics of graphs and slopes and areas, please check out this particular playlist, which is your class 11th playlist. All right, you can also search it directly on YouTube. If you go down over here, you will see the basics of physics, slopes and derivatives. Have taught derivatives, integration, or all this in these lectures. So please watch these classes. Only then you will be able to understand non-uniform motion, right? So let's begin with the class. With me, your captain Shreyas. Say hello to everyone. And if you are new, make sure you you put up your name, your city, etc., so that we also get to know more about you. Welcome Abhijit, hi Sanjuta, hi Tharuna, welcome Jiffy, Grief, welcome everyone, good evening, my dear lovely warriors. And last time I had given you an homework, and if you do homework, I'm pretty sure your name will not just be there in the comments, but also in the leaderboard. And guess what? 1 in 3 Vedantu students are cracking JEE Advanced. That's a high, very high selection ratio. So, my dear warriors, you are in the best coaching, you are in the best channel with the best teachers. All right. So, right now, I am seeing your names in the comment section. So, the last lecture which we conducted was, the vector multiplication and all of that. So, very good. Kudos to all of you. And if you have completed that class, amazing. The PDF is there every time in the description box as well as in the comment section right over here. Okay. Yeah, very good. Satish, Ramu, enjoyed the session. Very good, Sulochana. Very good, Sir Vector. I think I explained you that, Satish, right? Okay. Great. Let's begin. Good evening, Priya. Hi, Bhargav. I want everybody's names to be in the comments, okay? After the session is over. So let's start with all the basic terms. It's more like a revision, but we'll see it at a higher level also. Distance and displacement. So imagine there is a particle, there is some Pandu over here. Okay, this Pandu is going to meet Champa, and this Pandu goes like this. Maybe the road is like a ghat section. So the road is like this. So Pandu goes like that. So, he has traveled some distance. The length of the path is called distance. Distance, distance is nothing but the length of the path which you have traveled. So if I take this curved line, I think of it like a string and I stretch it on a scale. If it is 7 meters, the distance is 7 meters. If I measure this length to be 100 kilometers, the distance is 100 kilometers. Okay, so that is distance. It is obviously a scalar quantity. It is a scalar quantity, no need of mentioning the direction. But if Pandu considers how much has he displaced in this entire motion, his displacement is just the shortest line which joins is just nothing but the shortest line which joins the initial position with the final position. The initial position with the final or the current location. The final or the current location. That then becomes nothing but the displacement. So displacement is nothing but how much has your position changed. So it is change in the position, technically change in the position, and it is the shortest line from initial to the final location. Obviously, it is a vector quantity. It is a vector quantity. Usually, the symbol that I use for displacement, it is usually going to be S because it is a vector. I'll put a bar or you can put an arrow mark like this. And for distance, Usually use small d or capital D, whichever you prefer. Okay, usually D is the symbol used for distance. As you can see over here, if I am traveling like this, the length of the path will obviously be more than the shortest distance. So the length of the path being D, length of the path being just D, it will obviously be more than the shortest distance, which is the displacement. But imagine Pandu did not actually go like this. Pandu just moved along the shortest line. Maybe he had wings and he flew. He drank Red Bull and he flew from here to here. In that situation, that distance and displacement will become both equal. So usually you will see distance will be more than or equal to the displacement. Distance will be more than or equal to the displacement. It is more because usually the paths are curved, but in a unique scenario where you are going in a straight line without changing the direction, your distance and displacement both will be the same. Yeah, very good. Excellent. Next important thing is that the formula for displacement, I should have put it over here. Displacement is change in position. Usually the symbol for position is R. So displacement is nothing but change in the position. So delta R, which means it is final position minus initial position. Because these are all vectors, I should put bar symbol also over here. I should also put bar symbol over here. Okay. So displacement is nothing but change in position, final minus initial. Say for example, I tell you, you know, at time 0, that means initially, one Pandu is there and he is standing at x equals to 5 meters. Then maybe at t is equal to 3 seconds, the Pandu's position is, let's say, 20 meters. If you ask me how much is the displacement in this scenario, so it will be nothing but final position minus initial position. Final is 20, initial is 5, so it is nothing but 15 meters. So that is the displacement done in those 3 seconds. Final value of position minus initial value of the position. Position means coordinate. The location, exact coordinates is the position of any particle, body, bus, car, human being, anything. Okay, so that's why I put final minus initial will be the displacement. Visually, if you see on the number line, it will look something like this. If this is your x-axis, this is your origin. So maybe at time 0, this is where you are, and after 3 seconds, this is where you are at 20 meters. So obviously you can see this much is your displacement, which is of 15 meters. You have moved 15 meters from here to here. It's a vector quantity properly. If it was negative, that means you have moved along the negative x direction. So positive displacement means your coordinates are increasing. Negative displacement means your coordinates are decreasing. That is another interesting thing about distance. Distance always has to be more than or equal to 0. Your distance can never ever be negative. Never ever be negative. Even if I travel back, it can never ever be negative. It will always be either 0, that means I have not traveled, or at least some positive number, 0.1, 100, 1 lakh, something. But it can never ever be negative. Keep that in mind. That also brings me to the point that you can have sometimes that the distance traveled is 0. Sometimes the distance traveled is not 0. And displacement may be 0, maybe not 0. Maybe 0, maybe 0, maybe not 0. All possibilities are there. All the possibilities are there. Like over here, observe. Imagine I ask you, is it possible there is no distance and no displacement? Yeah, possible. Why not? Means you are at rest. Means you are at rest. Definitely it is possible. Is it possible that you have not traveled but you have displaced? That is impossible. I mean, if you move from one point to the other, you will definitely have to travel something. So this is definitely not possible. Not possible. Not possible. Because if there is displacement, there must be some distance. There must be some distance which you have traveled 100%. I have traveled something, but I have not displaced. That is possible because imagine a scenario where you move and you come back to the same point. That means initial location is equal to the final location. So I have traveled some distance, but final and initial locations are same. So displacement is absolutely zero. Possible. This is always possible. I mean, distance is there, displacement is there. Obviously, I move from here to here. Obviously, I have traveled some distance and obviously there is some displacement. So only this one is not possible. Is this absolutely clear? Hi Rama, welcome aboard. Yes, Newton's laws next month. Maybe around 3 lectures, Abhijit. Yeah. All right. Okay, tomorrow you have 9th kinematics exam. Well, this lecture will be definitely way more advanced for your 9th kinematics. Okay, but still you will learn a lot. Anyways, I have put up all the theory over here, whatever we have discussed, okay, in bullet points. So this will be very important for your revision, okay. Where are you going to get the notes? The notes you are going to get it in a PDF form. The link will be there in the description as well as in the comments pinned, okay. So you can download it after the class, maybe a day it will take, okay. Everything I have mentioned, it's scalar vector, positive, zero, more, less, etc. So let's do some questions coming up on your screen. Here it is. There is an athlete who completes one round of a circular track of radius r in 80 seconds. What will be the displacement at the end of 4 minutes 80 seconds? Okay, so he's completing a track of some radius and okay, the radius is also given to me. The radius is also given to me. The radius is, let's say, r, and for one round he takes 80 seconds. So first of all, let me see how much is 4 minutes 60 seconds. 4 minutes means 4 into 60 plus 4 minutes 60 seconds. Why? I mean, they could have just said 5 minutes, no? Why did they say 4 minutes 60 seconds? Is it something wrong over here? Okay, anyways, so 4 minutes 60 seconds is basically 5 minutes. It's 5 minutes. So 5 minutes means 5 into 60. So that is just 300 seconds. That is just 300 seconds. Okay. Now in this 300 seconds, how many rounds will happen? Let's think about it. Well, 80 seconds, one round. Another 80, 180 seconds, one more round. Another 80, that is basically your, 240 seconds. Okay. Another 80, that will make it 320 seconds. So, till this much, that is nothing but 240 seconds. 240 seconds. Plus, how many more seconds are remaining? 60 seconds are remaining. Plus, how many more seconds are remaining? 60 seconds are basically remaining. So, in these 240 seconds, 3 rounds will be done. 3 rounds will be done because 80 seconds is one round. So, in 60 seconds, how much of the rounds will be done? Think about it logically. Think about it logically. 80 seconds for one round. In 60 seconds, well, guys, if you think logically, you will understand. If 80 seconds are taken for one round, then for 60 seconds, how many rounds will be done? It will be exactly 3/4 of that particular round. Yeah, every 20 seconds you are doing a quarter. 20 seconds one quarter, 20 seconds one more quarter, 20 seconds one more quarter. So 3/4 of a circle, which is 3/4 of a round. So essentially what has happened is you have gone one round in 80 seconds, another round in 80 seconds, another round in 80 seconds, then 3/4 of the round. So from here, essentially you would have come over here. Yeah, everyone with me on this? You have gone like this many times. You have gone like this many times, but eventually you have just come over here. So this was your initial location and this is your final location. And they have asked what is the displacement. Displacement means you have to join from the initial to the final location. So that will be my displacement. I can clearly see, I can use Pythagoras theorem. If I just draw one line over here like this, this is base, this is 90 degree, this is r, right? So can you say now that s square is r square plus r square, which is nothing but 2r square. So that is s square. So therefore s will be nothing but root 2 times of r. So root 2 times of r is option number C. Everyone with me? So that is how we solve this question. Very good. Option C, very good, Gautams. Amazing, Abhijit, Varshini. Everyone, I want you to keep answering in the chat box. Keep it up, guys. And if you've forgotten to smash the like button, please do that right now. Yeah, I want to see that Josh, that energy, be it 9th, 10th, 11th, 12th dropper student. Full energy, full Josh, full concentration, full focus, full enthusiasm. All right. And show your attendance and support by smashing that like. All right. So, good question. It will take you definitely maybe around 30 seconds to maybe 50 seconds to solve this in the examination with practice. While explaining, obviously, I will explain in detail. Okay. Now, speed and velocity. That's the next terminology we need to focus on. Just like we had distance and displacement, we have speed and we have velocity. When we bother about direction, then we use velocity. And we don't care about direction, we talk about speed. Like you buy a new car and you're like, what's the top speed? And it's like, oh, 300 kilometers per hour. You get very excited. But you never ask the dealership, hey, is it in north or is it in south? Yeah, they will slap you. They'll be like, what are you talking, man? Are you mental or what? What do you mean by top speed of the car in north or in south direction? You are mental or what? Waste fellow. So there we don't care about the direction. But if I'm interested, oh, where is that aeroplane flying? I'm maybe a manager in the tower, air traffic control. I am interested not just in the speed of the aircraft, but also which direction, because it might hit some other aircraft. Where is it going to land? How much time it will take? I'm interested in all those things. Then I will be talking about the term velocity, because direction becomes important along with the magnitude. So just like before, over here, speed is nothing but your distance traveled distance traveled divided by the time taken, it is obviously a scalar quantity, and unit is meter per second or kilometers per hour, depending on whichever system you're using. When you talk about velocity, it is how much have you displaced. The displacement, it is nothing but the displacement, the whole thing divided by the time. Obviously, it is a vector quantity. It depends on the magnitude and direction, and unit is still going to be meters per second in SI units. You should also remember this conversion formula for meter second and kilometers per hour. So if there is some speed which is given to you in kilometers per hour, then you just multiply it by 5 by 18. Just multiply it by 5 by 18 so that you get the answer in meters per second. Say for example, Chuma, I'll give you some random example. Let's say it is 72 kilometers per hour. You put 72 over here. 72 by 18 is 4, so 4 5s are 20. So it will be 20 meters per second. Okay, so this is that conversion factor which you need to use. Okay, any other speed, like usually the speeds like 36 will be given. So you put 36 over here, 18 goes with 36 two times, 2 5s are 10. So it will be 10 meters per second. Okay, so this is that conversion factor which you need to use. So you will have the speed over here. Okay, and here you will put that same number, you will get it in meters per second. For example, I'll just put 36 over here so that you get the answer in 10 meters per second. Okay, fair enough. So formula wise, we will talk about average speed and average velocity. So usually the symbol for average is a triangular bracket. So when you have to talk about average speed without a vector symbol, then that will be nothing but the distance divided by the time. Okay, this is the symbol for average. This is nothing but the symbol of average. Wherever you see the symbol, for example, like this, it means average force. If I put like this, marks, and like this, it means what is the average marks in that school or that classroom. So that is the symbol of average. That's all. Don't get too much confused. If I put a bar, then I'm talking about velocity, and this means average velocity. So it will be nothing but displacement divided by the time taken again. But usually displacement is nothing but change in position, which is delta r, and the time taken, I can put it as delta t. So usually this is what the formula you will see in most of the books. Okay, so delta t means the time taken or the time interval, which could be maybe t. Okay, delta r, we have talked about it just before only. Delta r is nothing but the change in the position, which is displacement. Delta means change. Delta is a symbol of change, like triangular brackets were a symbol of, average, correct? So this is average velocity, change in position upon the time taken. Great. Yep. I'm pretty sure, Abhijit, you will definitely ask the question, but once you pay money, they will be like, okay, it's okay, even if he's mental, but he's paying his money, we'll sell him that car. Isn't it, Abhijit? Good evening, cutie pie. All right. Now, is there something like instantaneous? Yes, there is, but we'll talk about it in non-uniform motion. Today, we are more likely to discuss questions on average velocities and all of that. So, we'll not discuss so much on instantaneous as of now because non-uniform motion is a separate part. Apart from that, please watch these lectures which I have already told you, okay, right over here. Okay, the basics of areas and integration, and of course, this one over here. How do I get rid of this? This one, slopes and derivatives. Okay, watch both these classes, it is there in the playlist, so that your concepts of derivatives and integration are clear. Okay, we will not be teaching it again because it's already done. Okay, let's do some questions, but before going ahead, let me also tell you that speed will always be positive. Yeah, speed can be 0 or more than 0, but velocity can be positive, negative, or 0. Velocity can be 0, negative, or positive. Doesn't matter. It is just a vector quantity. So the negative sign signifies it's in the other direction. Positive means in the assumed direction wherever it is. 0 means you're not moving. So all three signs are possible for velocity, but for speed, it has to be a positive number. I mean, imagine you're riding a bike, your scooty, whatever, right? And it starts showing minus 20 kilometers per hour. You will be like, am I dreaming or what? Why is it showing minus 20? Then you might think, oh, maybe I'm moving behind. No, even if you go in the reverse, even if you're driving a car in the reverse, the speedometer should not show negative values. It is a speedometer. It shows the speed. It should always show positive values. It will never show negative values. Even if you drive in reverse, you drift, do whatever you want. Okay, so that is speedometer, which shows speed, which is positive. Yeah. Sir, given a time interval, can speed be 0 because it has covered some distance, right? Sir, in a given time interval, can speed be 0 if it has covered some distance? If it has covered some distance, obviously speed will be there. So if it has not moved, distance is 0. So no matter how long you wait, 1 hour, 2 hours, 1 second, the answer will be 0 speed. So only when distance is 0, speed can be 0. Okay, is that right, Varshini? Absolutely. Let's do some questions based out of it. Directly, I'm going to some PYQs because there is no point doing basic questions. I mean, that you do it in 9th and 10th grade. PYQs are not very difficult. You will see, which have been asked. JEE Mains 2023 10th April question. A person travels X distance with speed V1, X distance with speed V2. The average speed is V. Then the relation between V1 and V2 is. Okay, let's see. Always, I suggest my students start by drawing whatever is mentioned. The main mistake which students do is not visualizing. Visualizing means, sir, I should think like some Socrates or somebody is like philosopher, I should dream. No, no, that is not visualization. Visualization means you should draw. Yeah, like Leonardo. Okay, so you should draw, but not beautiful paintings, just simple diagrams. So let me show a simple diagram over here. All right, what is the diagram? I am traveling X distance. This is X distance. And then another X distance. Here I am traveling with a speed of V1. Here I am traveling with a speed of V2. How much time I took? I don't know. Maybe I took some time T1. Here I took some time T2. Okay. Why T1 and T2 are different? Because different speeds. Same distance, different speed. Obviously, more speed means less time. Less speed means I will take more time. So vice versa. Okay. Now I have been asked for this entire journey, how much is the average speed? So for this entire journey from here to here, the total distance will be 2x and the average speed will be v. That is the average speed v. Okay. So how do I find this average speed? It is nothing but the total distance by the total time. Now the total distance is very obvious. It is x plus x, which is 2x. Total time is t1 plus t2. Now here comes the trick. What is t1 and t2? We just spoke about what is the difference between time, distance, speed. Yeah, speed is distance by time. Okay, speed is distance by time. So if you think about it, speed is distance by time. Right over here, what will be this time? Time will be distance by speed. So it will be x by v1. And this time will be nothing but this distance by that particular speed, x by v2. Is that obvious? Speed is distance by time. So distance will be, time will be distance by speed. As simple as that. Okay, so instead of t1, I have to put x by v1. Instead of time t2, I will put x divided by v2. That's all I'm going to do. Okay, I will do plus, but before doing that plus, I can see something is cancelling x from numerator and denominator. So this is as good as 2 by 1 by v1 plus 1 by v2. Okay, so take LCM. So this will be 2 divided by, this LCM will be v1 v2. So this will be v2 plus v1 over here. Take v1 v2 on the top. So 2 v1 v2 divided by v2 plus v1, which is same as saying 2 v1 v2 divided by v1 plus v2. So 2 v1 v2 by v1 plus v2 is one way of writing, but I don't see such options. No worries. Don't worry. Just look over here. Instead of solving it here further, what if I take that? What if I take that v below and this whole thing on the top? If I take this whole thing on the top, this will become 1 by v1 plus 1 by v2 is equal to 2 divided by, this v was in the numerator, as it comes here, it will go below. So that is what I will get. So 2 by v is 1 by v1 plus 1 by v2, which is also option D. Yeah. So if you do not see the answer in the form that you have got, you need to modify, manipulate to get it in the required form, which is shown in the options. So as soon as I did it, I realized, oh, something is not working. No problem. I just went back and I see, oh, this is the way I have to get it. That's all. Is that right? Very good. Tarun Athogo, Varshini, Jayat. Awesome. Shreyas, what is V2? V2 is the speed in the second scenario. V2 is the speed in the second scenario. First distance, V1 speed. Second distance, V2 speed. They are two different speeds. That's all. Yeah. Great. Let's go to another question coming up on your screen. Okay. Let's see if you can solve this. The particle is moving in a straight line, covers half the distance with 6. The other half is covered in two equal intervals with speeds 9 and 15. The average speed during the entire. This is one crazy problem, okay? Although it is not a PYQ, can become a PYQ for sure. So imagine this. This is the distance that you have traveled. The half of the distance is traveled with 6 meters per second. So let's assume this is x. This is also x. The other half, I do not know how much speed it is traveling. But I know one thing. The other half is covered in two equal intervals. So maybe that some part of it, let's say I call it x1, which was maybe some part of it, which was, let's say, x1, was traveled in time t, and the remaining part, which is, let's say, x2, was traveled in that same time t. Equal intervals, time intervals means same time. Okay, so in that remaining part, maybe 5 seconds he's traveled with some speed, and the remaining 5 seconds with some another speed. So what are those speeds given? It is given as 9 meters per second and also given as 15 meters per second. Perfect. This is what is given to me. Okay. How much is this time interval? That is not given to me. So I will just take this as, let's say, T naught. This is T naught. This X distance, how much time interval time is taken? Not given. This, I just know equal times, but I do not know what is these X's. Crazy. I want to find what is the total average speed. The total average speed. Okay. So let's think. The total average speed will be the total distance. This is X, but that X is divided into X1 and X2. So technically it will be X plus X1 plus X2 whole thing divided by the total time. What is the total time? T naught plus T plus T. I hope this is absolutely clear. But one thing is there, this x1 plus x2 technically is nothing but x only. It is nothing but x only. So strictly this is 2 times of x and divided by T naught plus 2 times of T. T naught plus 2 times of T. Everyone with me? Yeah. Yes, caps keep going. Okay, great. All right. Now what do we do over here? I think we'll have to start substituting things. What is x? Well, x is distance. Speed is distance by time. So distance is speed into time. So x will be nothing but 6 times of t naught. 6 times of t naught. All right. Fair enough. That's one way of writing it. Or I can also write time, or I can also write time is distance by speed. So it will be x divided by 6. Time is distance by speed because speed is distance by time. So time will be distance divided by speed. Perfect. So maybe I'll have to start replacing these things one by one. So let's see what happens. Over here is equal to 2. Okay. And over here, instead of x, sorry, instead of t naught, I'll put x by 6. T naught, I am replacing by x by 6. I'm just keeping x as it is. Plus 2 times of t. Okay. T, maybe I'll have to write something. T, what is time? Time is this distance by this speed. So it is nothing but x1 by that particular speed. And this time is nothing but this distance divided by this particular speed. So each of these times is nothing but x1, x2, they are related with each other. But think about it, if I put, t as either x1 by 9 or if I put time as x2 by 15, then I won't be able to cancel these things, right? So maybe I need a relationship between x1 and x somehow. I somehow need a relationship between x1 and x. Without that, I wouldn't dare substitute that over here. How do I do that? Well, see, from here, I can say x1 is 90 and x2 is basically 15t. So if I add both of them, I should get x. So 9 plus 15, that is nothing but 24 times of t. Oh, perfect. So I've got t as x divided by 24. So why not substitute time as x by 24? That's all I am doing. See if this is absolutely clear in your heads. The time value I've substituted as x by 4. Why did I do that? Because if I put x1 or x2 here, it won't cancel. I will have many variables. So to get everything in terms of x, I have done this manipulation. x1, x2, I added them. x1 plus x2 is this total distance. So time and x relationship, I have substituted it over here. Let's start cancelling things out. X goes, this 2 goes with 24, 12 times, perfecto. So what do we get over here? 2 divided by, LCM is basically 12. So this will be 2 plus 1. This is nothing but 2 divided by 2 plus 1 is 3 divided by 12, which is as good as saying 2 divided by 3 by 12. That is nothing but 1 by 4. That is 2 multiplied by 4, which means it should be 8 meters per second. So which is option number D. Okay. So D is the correct answer. Loved the question, my dear warriors. Understood? Shravanand, too good. Welcome back, Shravanand. Abhijit, clear. Loved totally. Other method. Isn't it brilliant? I have not made the problem very lengthy. Okay, I've explained it in detail. I have kept as minimal equations, as minimal variables, as minimal assumptions as possible. Always draw diagram, do it properly. Or see, I mean, when I'm thinking also, I'm thinking very clearly. Okay, all the distances I have put here, all the speeds I have put here, all the times I have put here. It's not like jumbled up. So there is clarity in the thought also. That it all matters. How you solve your rough work, how you present yourself, even in the rough work. Not like neat handwriting, beautiful drawings and all of that. But is there clarity? If you come back to the same question after 5 minutes or maybe 1 hour, are you still able to carry forward from that rough work? Or else you are scratching your head, what is that rough work? What is this diagram? What did I do? Let me do it again. That is all wastage of time. So that is why bring clarity. Clarity is different from just presenting good like you do it in boards. All right, let's move to the next question on your screen. If a car travels 2/5 of the total distance with speed v1 and 3/5 of the total distance with speed v2, then what is the average speed? This is also a beautiful question on average speeds. These are common kind of questions. Again, start with the basics. So 2/5 of the total distance with speed v1 and 3/5 with speed v2. 2/5. So I'm dividing it into two parts. And sorry, 5 parts. Out of that, I consider 2 parts. So just imagine the total distance from here to here. Let's say the total distance from here to here. Let's assume this chumma as 5x. Just I'm taking it as 5x. So out of that, if I take 2 parts, so from here to maybe here, that distance will be 2x. The remaining part from here to here will be 3x. This 2x distance he is traveling with v1, the remaining distance traveling with speed v2. Question is, what is the average speed? Question is, what is the total average speed? Again, the total average speed will be the total distance, which is 5x upon the total time taken. Now, how do I know the total time? Well, this time will be t1, this time will be t2. How much will this time be? Distance by speed. So 2x by v1. How much will this time be? Distance by speed. So 3x divided by v2. So I just have to put over here time 1 plus time 2. So this will be 5x divided by, you have to put time 1 and time 2. Time 1 is 2x by v1. Time 2 is, what is it? 3x by v2. 3x by v2. As you can see over here, a lot of things get cancelled, like x, and x will definitely get cancelled. And I am left with 5 divided by 2 by v1 plus 3 by v2. So if you take the LCMs, so you will have v1, v2 over here. You will have 2v2 plus 3 times v1. So when you take v1, v2 on the top, it will become 5 times v1, v2 divided by 3v1 plus 2v2. So that's it. This is option number D. Yeah, 5v1, v2 by 3v1 plus 2v2. 3v1 I have brought it first, 2v2 I put it second. Right? That's it. Perfect. All right. Great. Loved the technique, Shankareshwar. I'm so glad. I'm so glad, Saranana. My energy is always good only because of you guys. And I love the fact that many 10th and 9th kids are also watching this. I was checking the analytics, the average age of our 11th standard videos. A lot of 9th and 10th standard kids are watching these videos. I'm guessing for Olympiads or maybe just out of general curiosity, or maybe you're preparing early for JEE NEET, whatever. Okay, so I'm proud of you guys. And I can also see a lot of dropper students also completing your backlogs, and even 12th standard syllabus, 12th standard students clearing your backlogs, which is very, very good. Keep it up, guys. Keep it up. All right. So always when you draw the diagram, things become very clear. If you show things and then you start making equations, it is obviously not a big task. Now let's do another kind of question. A particle is going with a constant speed in a circle. Ayo, why am I becoming blurred? What happened to me? One second. Okay. Is the focus fine? Yeah. A lot of Tamil students are there, Yogesh. Okay. So a particle is moving with constant speed in a circle. What is the magnitude of the average velocity? Average velocity after 1/4 of the rotation. Yeah, 1/4 of the rotation. Let's think. Okay, let's draw a circle first. Okay, and 1/4 of the rotation. So you were here and now you have come over here. Okay, so your initial location was here, now it is over here. You are going with a constant speed of v in the circle. So in this particular path, if you ask me, velocity, not speed, be careful. So I need displacement first. So displacement obviously will be just this much. This is my displacement. Well, this is radius, this is also radius. Is that right? So after 1/4 of the rotation. But there is a problem. Problem is, okay, if I want to find the average velocity, if I want to find the average velocity, which is nothing but displacement divided by the time. Displacement, I can still find it out using Pythagoras theorem, which will be root of r square plus r square, which is nothing but 2r square. So r goes out, so it will be r root 2. So the numerator I know is r root 2. R is not even in the options, number one. Number two, I don't even know the time. Yeah, do you see that? I don't even know the time, guys. So that is the problem. So how do you solve this particular question? Just think about it. Okay. So that is how minimal information is given in the JEE questions. You start thinking and doubting whether the question is complete or not. But then you need to think a little bit more. Speed is given. We have not even used it, number one. And it is going with a constant speed. So if it completes one circle, if it completes one circular motion, then the total distance it travels. So in one rotation, think about it, the circumference, which will be 2 pi r, will be the distance. That particular distance will be speed multiplied by the total time. Oh, yes. And if you think about it carefully, the total time I can break it down into 4 parts or 4 quarters. If from here to here, I'm taking time small t, so t, 4 quarters, so that will be 4t. So therefore, can I say 2 pi r will be v multiplied by 4 times of small t. This was for one rotation, but for each quarter, the time was t because you have gone for a quarter. What is the magnitude of average velocity after 1/4, which is a quarter? Is that right? So from this, I think we get r by t, if I'm not wrong. Just check this out. R and that t comes below over here. 4 times v is there and 2 pi is there, which is as good as saying 2v divided by pi, which is nothing but 2v divided by pi. So r by t, that's what I wanted, r by t. So t, I take it down, 4v is there, 2 pi, bring it down, 2 cancels, so 2v by pi. So r by t is nothing but 2 times v divided by pi, that's it, is equal to this into root 2. So the answer is 2 root 2 v, the whole thing divided by pi. That is your average velocity. That's it. 2 root 2 v divided by pi. Brilliant question, guys. How we did it? Minimal information was given. And what would you do if average speed was there? Just think about it. Okay. So that 4t and t part, if you did not understand, let me explain. For one rotation, let's say the time taken is t. Therefore, for one fourth of rotation, the time taken is, let's say, small t. What will now be the relationship between these two? This total time will be 4 times of small t, isn't it? Or this small t will be capital T by 4. Is this now clear? Absolutely. That's why we put t as 4 times of t over here. Okay, that is what I have done. I have put t as 4 times of t over here. Clear, everyone? Good question, Haruna. Nice. Loved it. Amazing. Is it understood now, Abhijit? Clear? So once I got that, I deliberately looked over here. I saw R and T were required, R by T. So from this, I understood if I just take that small t below this R, I can take the 2 pi below. So it will be 4v by 2 pi, 4 times v by 2 pi, which is as good as saying 2v by pi. So instead of R by T, I can take this and directly substitute it over here. That will give me the answer. Clear? That kind of manipulation you will need. Right? Clear, says Jaya, Shivu, everyone. Loved these questions. So as you can see, kinematics, a lot of people ignore this chapter. They think, oh, I can do it, I can do it. But when this kind of questions come, you're suddenly stuck. And what happens is, the scary part is when you're stuck in a simple question and you know it is simple, then it lowers your confidence in the exam. You might have experienced it, right? And you feel, oh my God, why am I not able to do this? Am I going wrong? What has wrong? What has gone into my head? Why is my head clogged? And you become more nervous. So that is why don't take it for granted. Any chapter, no chapter is easy. No chapter is difficult. If you solve many problems, everything will then come to you naturally. Then you cannot be overconfident. Everything will start coming as you go. With the flow, you will start solving all the questions, isn't it? Yeah. Right. All right. In HCV, no solution is given. You will find the solutions on the web. Many solutions are there. If you just scan through the web, no, you will get it. Yeah. Don't worry. Okay. Now let's go to acceleration. Acceleration. Acceleration is nothing but acceleration is the rate of change of velocity. So we define now average acceleration. We will talk about instantaneous later on. It is nothing but how much is your velocity change. So delta V upon the time taken, that is delta T. Many books also write it as V final minus V initial upon delta T, or sometimes people use the symbol, or sometimes people also use the symbol just T. Delta T or T, they sometimes alternatively use the symbols. It's the same. Delta V is the change in velocity, which is final minus initial velocity. So this is the formula for your acceleration. It is a vector quantity. It is a vector quantity, and the SI unit is obviously meters per second square. It is meters per second square. Now, just to give you some idea about acceleration, let me show you certain scenarios. Say, for example, there is a particle which had a speed of 2 meters per second, and after some time it gains a speed to 5 meters per second in, let's say, 6 seconds. In, let's say, 6 seconds. Then the acceleration will be final minus initial divided by the time. 5 minus 2 is 3. 3 by 6 means 0.5 meters per second square. 0.5 meters per second square. Is that right, everyone? Similarly, another example. Let's say there is a particle which is going like this, and the speed reduces over here, maybe. Okay, maybe it reduces like this, and maybe throughout the problem solutions we are taking right side as positive direction, and the left side we are taking negative direction. So as you can see, when I substituted the velocity, keep in mind they were vectors, v final, v initial. So I've substituted final as positive 5, initial also as positive 2. Okay, because the velocities were directed towards the right side, which is the assumed positive direction. In this scenario, let's say, for example, the initial speed might be, let's say, 7 meters per second. Maybe the final speed is, example, something 1 meter per second. And all of this happens in, let's say, 2 seconds. Okay, all of this happens in 2 seconds. Now, if I want to find the acceleration, here is what I will do. Again, final minus initial by the time interval. Final is not 1, rather it is -1. Why is it -1, guys? Because it is in the negative direction. Initial is not +7, it is -7. Look at the arrow mark, it was going this way. So this way is negative, that side is positive. The whole thing divided by the time interval. So this is as good as saying minus 1 plus 7 divided by 2, which is 6 by 2. Therefore, acceleration is 2 meters per second square. Now, when I see acceleration is 2 meters per second square, 6 by 2 is, sorry, why did I put 2? My bad. 3, 3 meters per second square. The moment I see the sign of acceleration, which is positive, where will I show it? Left or right? Acceleration has come out to be positive by proper sign convention usage. So, therefore, I will show the acceleration in this direction. Yes, it is accelerating in that direction. Is that clear, everyone? Yeah, perfect. Now, you might be wondering, sir, wait a minute. How come the speed was reducing but acceleration is positive? This is the most common misconcept which students have in their heads. If acceleration is positive, then it should increase the speed, and if acceleration is negative, speed should decrease. That's what would have been taught to you in school also. Correct me if I'm wrong. Yeah, we have a lot of kids out here. Yeah. So that is not correct, guys. So remember one very important thing, which I'll put it on the next slide. In fact, if you want. Okay, so it is nothing but if your velocity the pink one, let's say, is the acceleration, and the blue one, let's say, is the velocity. So in this particular scenario, when acceleration and velocity are in the same direction, then always the speed will increase. Keep this in mind. The speed increases. The speed increases. And you can see it is accelerating by increasing the speed. Whereas when velocity and acceleration are in opposite direction, then you will see that the speed is reducing. The speed is reducing. As you can notice over here, velocity is positive, velocity here is negative, whereas here acceleration is negative, here acceleration is positive. So the signs are opposite, then the speed will reduce. But here acceleration is negative, here acceleration is positive, here velocity is also positive, here velocity is also negative. So the signs are similar, then the speed increases. Is this absolutely clear, my dear warriors? Everybody with me? So this is one scenario, and of course, this is another scenario. The last scenario is where you have some velocity, but acceleration is zero. Such a scenario, we can call it that it is a uniform motion. Uniform, uniform motion. There is no acceleration at all. Okay, it is going with constant velocity. Just because acceleration is zero does not mean velocity is zero. It has constant velocity. Constant velocity. It is not changing, so acceleration is zero. So that is also a possibility when there is no acceleration at all. Is this clear? Everyone with me on this? Three different scenarios. Perfecto. All right, from basics to advanced for English aptitude in variety, SRMJ. Lord, I wanted to also know from all of you, how many of you also plan to move abroad for studies, maybe planning to write the SAT exam? Are you guys interested in that? Let me know. Because if so, because I received couple of messages on Instagram and Telegram saying, sir, why don't you start SAT related material also, especially the aptitude part, the mathematical part, or the subjective part and all of that. If if you are interested, let me know. Then if we have a lot of people, then we can think about it. Yeah, because we have been training on the sidelines, and I was to train personally long time back students who went abroad. A lot of my kids are right now in Canada and US also. No, I don't know how many of you know this. If you want, let me know. Okay, we can think about it. Yeah, on YouTube. Yeah. for masters. Many of you plan for masters, but not for graduate. I understand. A lot of people do say that. Okay. Now, let's talk about uniformly accelerated motion. So this is the next part. What is the meaning of uniformly accelerated motion? Uniformly accelerated motion. Whenever these situations arise, that means one thing is clear, that the acceleration is constant. Acceleration is constant. So say for example, there is a car over here which is right now moving at some speed. After some time, this is the speed. After some more time, this is the speed. After some more time, this is the speed. So maybe I take a time gap over here from here to here. Okay, from here to here, let's say we wait for 3 seconds. Then from here to here, let's say again 3 seconds. Let's say from here to here, again 3 seconds. So every 3 seconds or 2 seconds or 1 second or 0.5 second or 0.7 second, I'm measuring the speed. And let's say initially the speed was 1 meter per second. Then maybe it became, let's say, 7 meters per second. Then maybe it became, 13 meters per second. Then maybe it became 19 meters per second. This is a uniformly accelerated motion. I'll tell you why. In every 3 seconds, the speed changes by 6. 3 seconds, the speed changes by 6. Yeah, every 3 seconds, the speed is changing by 6 meters per second. In fact, you can calculate the acceleration also. So, acceleration will be 7 minus 1 by 3. Acceleration will be 13 minus 7 by 3. Acceleration will be 19 minus 13 by 3, right? So if you notice, the acceleration is nothing but 6 by 3, which is 2 meters per second square. So which is a constant value, which is a constant value. So this is a uniformly accelerated motion. The speed could be increasing or decreasing, doesn't matter. Please do not confuse it with uniform motion. In uniform motion, velocity, your speed will be constant, no change in the speed. You are going like that. Okay, here your speed is increasing or you are decreasing. You are braking or you are suddenly pressing the accelerator and zoom, you are going like that. So that is uniformly accelerated motion. A lot of examples are there: a braking car, an accelerating car, of apple falling from the tree, a ball thrown up in the air. All these are accelerated motions with constant value of acceleration. Is that right? Okay, everybody with me? The girl who is born for me. Oh, yes. Wow. My God. Nice goals, yeah, Yogesh. Okay, great. Sir, but not possible in real life? No, definitely it is possible. Why not? You can definitely have uniformly accelerated motions in real life. An apple falling without air resistance is uniformly accelerated motion. Yeah. A car whose speed is constantly increasing at a certain rate is uniformly accelerated motion. You apply constant force to brake it, that force will produce uniform retardation. Okay, so everything is possible. By the way, whenever speed is reducing, you usually call it as retardation, retardation or deceleration, or deceleration. Usually that is the word which is used. All right. Now, whenever you have such uniformly accelerated motions, we have some common variables. Like for example, the original speed at time is equal to 0 is u. Then maybe after some time, maybe your speed will now newly become, let's say this is at t is equal to some t seconds, 5 seconds, 100 seconds, 0.5 seconds, whatever. The speed will become v. So this is your initial velocity. This is your final velocity. And in this process, maybe you have moved some displacement. You have moved some displacement. Let's say it is s. S is nothing but the displacement, not the distance. It is the displacement. And this is a uniformly accelerated motion. So that means your acceleration will be there and it is obviously constant. It is constant. In such cases, we have some ready-made equations which will help us solve many scenarios. I know the acceleration, what's the speed after some time. I know the velocity, what's the displacement done. I know the displacement, how much might be the acceleration. All these scenarios can be solved. So let's start looking at it. What are the equations one by one? Starting with the first kinematic equation, which has final velocity. Then for the second kinematic equation, you have the displacement. And for the third kinematic equation, you basically get v square, the final speed square. There is one more additional equation we'll be talking about in a bit, but let's see these first. So first one is v is equal to u plus acceleration multiplied by time, plus acceleration multiplied by time. The second one is displacement is initial velocity multiplied by time, plus you have over here half times acceleration into the square of the time. And the last one, v square, is u square, initial speed square, plus 2 times of acceleration multiplied by the displacement. Multiplied by the displacement. These are the three major equations which we'll be using very regularly. Yeah. Please remember, only when acceleration is constant. Sir, but in real life, like Abhijit pointed, acceleration may not be constant, sir. What to do? We are dedicating an entire lecture for that. That is called non-uniformly accelerated motion. There, we need to use derivatives, integrations, slopes, areas. Okay? So, we'll be using that concepts in that dedicated lecture out there. For now, just remember, uniformly accelerated motions, we can use these particular equations. So let's block them off, the most important equations. First kinematic equation, second kinematic equation, and the third kinematic equation. Please remember that they are all sign sensitive. They are all sign sensitive. So you need to assume some direction as positive and some direction as negative. All right. I love derivatives, then you're going to love that lecture for sure. Yeah. Yeah, there is another one I know, formula. We are going to come to that. Like I said, one more equation is there. I'm going to talk about it after some time. First, let's do questions on this. That is the displacement in nth second. We are going to come to that. Don't worry. Okay. Let's start. Here is the first question. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 to 20 while passing through a distance of 135. The value of time is interesting. Draw. Always start by drawing. Always start by drawing. Okay, this is that distance you have traveled. Okay, I don't know how much distance. Let's just assume it as s. Okay, no harm. The velocities are given. Initial velocity, I think, is given as 10 meters per second, and the final velocity over here is given as how much? 20 meters per second. Oh, displacement is given. How much is the displacement? 135 meters. So it is given 135 meters, but the time is not given. Even the acceleration is not given. Yeah. Ray optics could be a long time. Okay, it will take some time because we have magnetism in between and all of that, right? So it will definitely go till August end. So maybe by August end or September, we should be doing ray optics, wave optics, and then modern physics. That's it. We are done with the syllabus. Yeah, cool. Okay, so how do we do this? First, let's assume that there is some kind of acceleration. Let's assume some kind of acceleration. I do not know. Is there any equation which can give me time? V is u plus at, but I don't know a. But displacement is given, speeds are given. So maybe the third equation might help me. How? Observe carefully. V square is u square plus 2a into s. Final velocity is 20. Okay. Initial velocity is 10. Acceleration, I do not know. Displacement is 135. 20 square is 400. 10 square is 100. 2 into 135. 13 to the 16, so 260. So 270. So 270 times of A. So therefore, if I build 270A over here, that will be 400 minus 100. 100 over here, 400 minus 100. So left out is 270A. So therefore, 400 minus 100 is 300. And this is nothing but 270A So therefore, A will be nothing but 300 divided by 270, 0 cancels, which will be 30 by 27. 30 by 27 also we can divide it by 3, which is 9 divided by 3 is 10. So acceleration is 10 by 9 meters per second square. That's the first thing which we get. Okay. But hold on. We are not done yet. We have to find the time, right? So what do we use? Time is needed. Acceleration is known. Oh, V is U plus AT. So V is U plus acceleration into time. Final velocity 20. Initial velocity 10. Acceleration 10 by 9. Time I do not know. Okay. So this will be 20 minus 10. 20 minus 10 is equal to 10t divided by 9. So 20 minus 10 is 10. So it will be 10 is equal to 10t divided by 9. 10 cancels. So 1 is equal to t by 9. That means that time is 9 seconds, which is option number D, of course. Is it clear? No, it is not B. It is not 1.8. It is D option. 9 seconds. Very good, Jain. Okay, very good, Varshini. Okay, Tharuna, correct. Yes. Abhijit, be careful. All right. Will we really complete our 11th syllabus till October and for all subjects? Around that time should be a good time. Yeah. Maybe around that time. Maybe 11th syllabus might take a little bit more time because it's little bit vaster. It's more vast than the 12th syllabus. So maybe. I don't know. We'll keep a target. Okay. Let's do the next question coming up on your screen. A bus is moving along a straight highway at this speed, halts within 4 seconds. The travel distance by the bus during this time, assume uniform retardation. Okay. So first of all, this is how the bus is going. Let's say the initial velocity was like this, and 72 kilometers per hour. First convert it into meters per second. So 72 multiplied by 5 by 18. 18 goes with 72 4 times. So it is nothing but 20 meters per second is initial speed. It finally comes to a halt. So final velocity will be 0. And the total time taken for it to stop is given to be 4 seconds. And the question is distance traveled. So maybe the distance traveled is x, or you can just say it is s. S is the distance traveled, which is what is asked. Okay, fair enough. Acceleration is not known. So acceleration will be negative. Just think about it because it is retarding. So acceleration will be directed this way. Fair enough. Let's start using some equations. I think I need the acceleration to find the displacement. So time is given. So S is ut plus half at square. S is ut plus half at square, no. But V is u plus at, I can use. See, V is u plus a into t if I use. Final velocity is 0. Initial velocity 20. Acceleration is negative value, some negative a. Time taken 4. So therefore, 4 times of a is 20. Therefore, 20 by 4 is nothing but 5. So 5 meters per second square is the retardation. It is a retarding. I have got positive value, don't get confused, because I have taken acceleration already as negative over here. Okay. So minus sign has been put. Yeah. Next important thing, we have to find S. S is ut plus half at square we can use. So S is ut plus half a times t square. Initial speed is 20. Time 4. So plus 4 plus half times. This a is technically negative a. This is acceleration, that a is negative a, so which is minus 5. Don't put positive a, else you'll get a wrong answer. Time taken is basically 4. All right. So what will happen? 20 into 4 is basically 80 minus this will be 5. 4 square is 16 by 2. 2 goes with 16 8 times. 8 5s are 40. So 80 minus 40, which is 40 meters. So the displacement is 40 meters, which is the correct answer. So many of the times you might be needed to use 2 or 3 kinematic equations. Perfecto. All right. Great. Awesome. Awesome. Perfect. Shall we go ahead? Shall we go ahead to the next question coming up on your screen? Here it comes. Here it comes. A body is sliding on a smooth, okay, smooth inclined plane and it takes 6 seconds for it to reach the bottom from the rest at the top. How much time does it take to cover 1/9 of the distance starting from rest at the top? Okay, let's draw it first. This is from the top to the bottom. Okay, and it is starting from rest. So here the initial velocity was 0, and here it might have some good amount of speed. Maybe this total distance, let me assume it as x. Okay, and it takes how much time to go from here to reach the bottom? 6 seconds. So here when it reaches, time is 6 seconds. The question is, how much time does it take to cover 1/9 of the distance? 1/9 of the distance means only from here to here maybe. This is, let's say, x by 9 distance. So question is, how much time does it take? So how much is that time which it takes to go from here to here? That is the question. In this entire situation, they have not mentioned how much is the acceleration. How much is the acceleration? Okay, maybe if I find the acceleration, my job will be done. So start off by finding the acceleration. Can we do that? Maybe x is given, initial speed is given, time is given. So displacement, time, acceleration. S is ut plus half at square. So let's use S is ut plus half acceleration into time square. The displacement right from here to here is basically x. Initial speed is 0. Time taken doesn't matter. So 0 is there. Plus half acceleration I do not know. Time taken is 6. So 6 square. So therefore, x is equal to 6 square is 36 multiplied by a divided by 2. 36 by 2 is 18. So x is nothing but 18a. Therefore, a is nothing but x divided by 18. Okay. So I'll just keep it as it is over here. I will not touch it. Now let me go to this part. From here to here. Let me again use the same equation for that part. The displacement is x by 9. Initial speed is 0 plus half into acceleration is x by 18 into time square, which I do not know. The best part over here, can you see x and x just got vanished, cancelled out? Perfect. That's what I need. So 1 by 9 is equal to 0 plus anything is that anything. So t square is there. 18 twos are basically 36. Well, 9 and 36 definitely cancel out. That will become 4 times. Yeah. So that 4 goes on the top to t square. So that is t square is 4. So t is basically 2 seconds. So obviously it will take 2 seconds, which is option number B. That is the correct answer. As you can see, if you show the data properly, if you assume the variables properly, you solve it by the proper sign convention with the proper diagram, very easily you can get any kind of question. Yeah. Welcome, Kurvashin. Yeah. Will PYQ concept repeat? 100% Girish. Forget in JEE means in the same, attempt from one shift to the next shift also it repeats. From morning to evening also it repeats. From April to January also it repeats. From 2022 to 2023 also it will repeat. Maybe from 2019 some question will repeat in 2025. So these kind of repetitions do happen, and not once, very rarely. Many questions, pattern, model, concept will get repeated. Okay. So, but that does not mean question itself will get repeated. Yeah. Perfect. Let's go to another question coming up on your screen. Here it is. A small toy starts moving from rest under constant acceleration. If it travels 10 meters in t seconds, how much distance will it travel in the next t seconds? Wow. How much will it travel in the next t seconds? Okay, let's assume this is how much it has traveled in the first time, and then it has to travel some more distance in the next t seconds. So let me just put it like this. So it has traveled a distance of 10 meters. Okay, it starts from rest over here under constant acceleration. Okay, acceleration is there. Then over here it has traveled some more distance. I do not know how much it is. Maybe it has some speed over here v1. Maybe it has some speed over here, which I can assume it as v2. There is the same acceleration over here. how much more distance will it travel in the same time. So here the time taken is t. Obviously, the same time is also taken over here. I have an idea. Let's use the second kinematic equation, s is ut plus half at square, because we do not know the final velocity. So if we take the first part, using s is ut plus half at square, the displacement is 10 meters. You are starting from rest. Acceleration I do not know. Time taken is t. So basically, can I just say that 10 multiplied by 2 is 80 square, or basically a is nothing but 20 divided by t square. Acceleration is 20 by t square. That is what I'm getting. Okay, I'll just keep it as it is. If I consider the complete distance, that will be 10 plus x. That will be 10 plus x. Can you see that? 10 plus x will be the complete distance. If I use the same equation which I have used over here, the total distance will be 10 plus x, will be initial velocity will be 0. Why did I do that? Because if I used this much part for calculating s, I do not know v1, the intermediate speed. So for that, I'll need one more equation. I don't want to break my head so much. So I took, okay, let's take the total displacement only. So I don't have to bother about the intermediate speed. Got it? That is a trick which I have used. U is 0. Else this u will not be 0 if I consider only this much part, because some speed will be there. Plus half times acceleration times t square. Now beware, for this entire event, the total time will be 2t, t and t. So a lot of people will make a mistake here. Yes, so that will be 2t square, and acceleration just substituted from here. It is 20 by t square, just as it is. Okay, perfect. So 10 plus x is equal to 20 by 2, that's 10. This is t square, and this is 4t square. As you can clearly see over here, t square and t square just got cancelled. Okay, so what is there? Ha 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 ha. Okay, 10 plus x is equal to uh, 10 plus x is equal to 40. So therefore, x is equal to 40 minus 10, which is 30 meters. So the next distance is 30 meters. That is option C. C for Captain Shreyas, of course. Perfecto. Yes, Taruna, I think some autofocus is on. I don't know how to turn that autofocus off. I know it, how to turn it off, but the problem is the moment I go here and turn that autofocus off, then it focuses very closely. And when I come back here, the autofocus is off. So I need another person in the room when I'm standing here to turn that autofocus off so that the focus is on the board. Or else when I move there, by the time I change the setting, it will not adjust here. So yeah, that's the problem. Okay. So in this particular question, if you see Shankara, what happened is the toy is moving 10 meters in the first 10 seconds. How much more will it move in the same t seconds? Sorry, t seconds. How much more will it move in the next t seconds? So initial distance 10, final distance, I don't know. I have assumed it. Same acceleration, times are same from here to here t, here to here also t. So if I take the total distance, it will be 10 plus x over here. For this part, I used s is ut plus half at square. Initial speed was 0 because it was given from rest. I saw acceleration to be 20 by t square. That same acceleration is also here and here also. So for the entire journey, the total distance is 10 plus x, ut, u is 0, so 0 plus half into acceleration into time square. Time is not just t, but t plus t, which is 2t. So solving this, you will get x is equal to 30 meters. Cool? Fine, Shankar? Okay, great. Let's do another question coming up on your screen. A particle is having certain speed. Oh my God, again it became blurred. Particle is traveling with certain speed, moves with constant acceleration for 15 seconds. What is the displacement in the last 2 seconds? That's the question. Yeah. Thank you for all the love. Kavya, thank you so much. Thank you for all the love from Kerala. And thank you for all the love from Tamil Nadu too. It was lengthy. All right. No issues. Let me tell you that this problems might look lengthy initially, but after you reach in 12th standard, sir, I used to tell that problem was lengthy. Actually, that was solvable in 20 seconds. That's how you will say. You only will come and tell me. Okay. So don't worry. Initially, all the problems might look difficult, lengthy, this, that. That happens when you enter 11th standard because you're used to, like, see, the mentality in school, unfortunately, the sad part of our education system, it trains us that the moment you see the question, solution should be there in your head. That's how your school has trained you for 10 years. So you expecting me to change it in 1 minute or 1 hour is unjustified. But when students are preparing for JEE, NEET, or any Olympiads or competitive exams, then the mentality is completely different. The moment you see a question, you cannot see the solution, or you do not know how to solve it. You try few things and then you get stuck, you come back. You try, oh, from this, I need that. So you then try something else and then you find something else. Oh, then you connect the dots and then you do something and then you arrive at the final answer. So, there is no clear path of how to solve the questions. And you slowly get enlightened as you proceed and as you do some trial and errors. And when you have enough practice, then you know where you might get stuck, which you should not do, what method will work, or which method will take longer time, and all of that. So, you need to slowly come out of that school mindset where the moment you see a question, I know how to solve it. No, no, no. It does not work like that for JEE. All right. Cool. So let's solve this. Particle is going with an initial velocity of some 10 meters per second. So let's draw that diagram. 5 meter for 15 seconds along a straight line. Okay. Initial velocity is given to be 10 meters per second. And here I don't know the speed, but the time I know. How much is it? 15 seconds. So time is basically 15 seconds. Okay. And acceleration is also given to me. Acceleration is also given to me. How much is it? 5 meters per second square. Last 2 seconds. So last 2 seconds means just this much. Just this much. So technically, if you see, this will be 13 seconds. So from here to here, I would have moved some amount. From here to here, I would have moved some amount. I need to find this particular x. I have been asked how much is this particular x. I think this x will be the total displacement in 15 seconds. The total displacement in 15 seconds. From that, you subtract the displacement which is done till 13 seconds. Just check this out. Does that make sense to all of you? This much displacement is the total displacement till 15 seconds. From this, you subtract this much, which is displacement in 13 seconds. So from this, if you subtract, remaining will be this much. Does that make sense to all of you? Okay. So use ut plus half at square. So initial speed 10, time 15 plus half into 5 into 15 square. That is first displacement. Second one, u is basically 10, time is basically 13 minus half, plus half into 5 into 13 square. Just do the math and now you will get the answer. That's it. So you just have to solve this and quickly tell me how much answer are you getting. Come on, guys. Got it now? Okay. Shipali saying 160 meters. What about others? Happening when I'm in 9th preparing for JEE. Happens, Abhijit. Correct. Very true. I'm so glad, Shankar. 160. Everyone. Come on. Let's see how many of you can do this. Come on. Calculation part, at least you can do it very quickly. 15 square, 225. 13 square, 169. Yeah, you can subtract 225, 169, here 150, and here 130. Subtract it, you will get the answer as 160 meters. Okay, just try it out quickly. You'll get the answer as 160 meters. Perfecto. Perfecto, Dharunaja, Shankar, excelente. Now, this might probably lead you to the last concept of today's class, which is kinematics for nth second, distance traveled in the nth second. Okay, so what does this nth second mean? So maybe there is somebody who is Papa traveling like this. along a straight line, uniformly accelerated motion. Nth second means, say for example, this is where you are at t is equal to n seconds. 1 second before, exactly where were you? This is where you were, t is equal to n minus 1. So, this much distance that you see over here, this is the displacement in the nth second. Basically, displacement, distance traveled in the nth second, distance traveled in the nth second, which is written over here. It is nothing but your SNTH. It is, mind it, displacement till n seconds and displacement till n minus 1 seconds. If you subtract them, that is what you will get. Displacement from here to here minus displacement from here to here. So from this, if you subtract this, this will be remaining. So from this, it is displacement till n seconds, and displacement till t minus n1, t is equal to n minus 1 seconds. So if you take this out, this much will be remaining. So it is as good as saying it is Sn minus Sn minus 1. You can solve this very easily. It will be u into time is n plus half into a n square minus u into n minus 1 plus half into a into n minus 1 whole square. So you need to solve this, that's all. Un plus half a n square. This will be minus un, minus will be plus, so plus u minus a by 2, and n minus 1 whole square means n square plus 1 minus 2n. That's what it is. So this will become nothing but un plus half a n square minus, actually, okay, minus un plus u minus a n square by 2. I'm just opening up the brackets. So minus a by 2 minus a by 2, minus is plus, so plus 2 cancels, a times of n. A lot of things will definitely get cancelled, like this un over here and this un over here, half a n square, and this also will get cancelled. So you will be left with nothing but, what is there? U is there, and plus an is there, minus a by 2 is there, which you can solve it as u plus a by 2 into 2n minus 1. That is your displacement in the nth second. That's the derivation for it. Okay, I just derived it. It's like the previous problem, but instead of 2 seconds, it's just the last second. That's all. Yeah, how much is the displacement in the nth second? That's it. So nice formula, right? A lot of things were there, but see, it became so laddu. So if you write it as a by 2 common, it will become 2n minus 1. Now there are some very interesting repercussions of this, like for example, see guys, if I give you an example, say initial velocity is 7 meters per second, acceleration is, let's say, 4 meters per second square. Find the displacement in fifth second. Find the displacement in fifth second. How do you solve it? Here is the solution. So displacement in fifth second is asked. So use the formula u plus a by 2 into 2n minus 1. Initial speed is 7. Acceleration is 4. N over here is 5 and minus 1, of course. So this will become 7 plus 4 by 2 is 2 multiplied by 2 5s are 10, 10 minus 1 is 9. So this will be 7 plus 9 2s are 18. So this will be nothing but 25 meters. So immediately you can get the answer. Immediately you get the answer as 25 meters. Is that right, everyone? Very good. Excellent. Another interesting thing about this is, say for example, there is a particle which starts from rest. Imagine there is a particle which starts from rest that means initial velocity is 0. If you find displacement in the first second, which will be 0 plus a by 2 into 2 into 1 minus 1. 2 ones are 2, minus 1 is 2 minus 1 is 1, so it will be just a by 2. If you find displacement in the second, u plus a by 2 into 2n, n is 2 minus 1. 2 2s are 4, 4 minus 1 is 3, so 3a by 2. Displacement in the third second, initial velocity 0, a by 2, 2 into 3 minus 1, which is 3 2s are 6, 6 minus 1 is 5, so 5a by 2. Displacement in the fourth second, u plus a by 2 into 2 into 4 minus 1, 2 4s are 8, 8 minus 1 is 7, so 7a by 2. As you can see, a by 2, 3a by 2, 5a by 2, 7a by 2, next will be 9a by 2, next will be 11a by 2, all odd numbers. So it says that the displacement in the first second to the displacement in the second to the displacement in the third second to the displacement in the fourth second, and so on and so forth, will be in the ratio of 1 is to 3 is to 5 is to 7, and you can proceed more also. So basically odd numbers ratio. If you take equal intervals of time, you will see the displacements are in the odd number ratio. Is that absolutely clear, everyone? So I can mention this very important property. The displacements in equal intervals of time for a particle starting from rest, for a particle accelerating from rest is in the ratio of 1 is to 3 is to 5 is to 7 is to 9, like that, odd numbers basically. This is a very, very important property. Very, very important property. Yeah. Great. Yes, Shankara, we will be doing problem solving sessions as the syllabus ends. And last year we have done PYQ series of all the PYQs. This year also we'll do some PYQ series, and of course mock tests and all those problem solving sessions will follow. Yeah, don't worry. You can see even the old problem solving sessions. That will definitely be a good boost for your skills. Yeah, you can watch any of the old classes also. A body travels so and so meters in the nth second and so meters in the n plus 2th second. The acceleration is, wow. So let's understand each part separately. This much in the nth second means if I use our formula, which is displacement in nth second is u plus a by 2 into 2n minus 1. If I use this for the first part, 102.5 will be u I do not know plus a I do not know, 2n minus 1. For the second part, if I use it, this one, okay, this one, I can say 115 is equal to u I do not know, acceleration I do not know, n will be 2n plus 1, sorry, n will be n plus 2, so 2 into n plus 2 minus 1. So wherever n was there, I will put n plus 2. That's the only mathematical difference. So therefore 115 will be u plus a by 2. This will become 2n. 2 to the 4, 4 minus 1 is 3. So 2n plus 3. Now I think best thing is to subtract this. So if I put 102.5 is equal to u plus a by 2, and here I have 2n minus 1. Just if you subtract these two, I think it will be the best thing to do. So 115 minus 102.5, u got cancelled, a by 2 is common. So even our 2n will get cancelled. Think about it. 2n will get cancelled. 3 minus minus 1 will be there. Is that right? Solving this, you will definitely get the value of a. Just check it out. How much is the acceleration quickly? Yeah. What I did was clear. I just took this equations for this one, this for this one. Here n was replaced by n plus 2. This will be 2n plus 4 minus 1, which is plus 3. When I subtract, I saw u got cancelled. Even this 2n got cancelled. N is not needed. So solving this, you will definitely get the answer. Just check it out quickly, my dear warriors. Yep. Tell me the answer. Yep. Come on, guys. This will be 12.5. 2 will go on the top. 3 minus minus 1 is 4. Yeah. 25 by 4. 25 by 4, which is how much? 6.25. 6.25 meters per second square. Correct. Very good. Option A. Excellent. Awesome. Can I watch this for JEE Advanced also? Of course, Sarvesh. Definitely. So I think that was the last question. And let me also remind you that you are going to find my entire lecture series of 11th and 12th in VBuddy in the Sigma batch. Along with me, you have the best teachers for physics, chemistry, maths. You obviously have Diksha ma'am, me, and Namrata ma'am. Apart from that, we have, PNJ sir, everyone who are themselves IITians and IITians and, have been producing consistent results in the Sigma batch. It's a very affordable batch. Do check it out. The link is there in the description box. If you are a 12th standard student, you should definitely consider it. But if you are a 11th standard student and you are looking for a proper 2-year course, then you should definitely check out the pro batches. The pro batches are a proper systematic way of studying, and through which we have been able to produce amazing toppers, consistently. Even the students that you saw, all India rank 15 or getting 128 or 120 in maths JEE Advanced. All this was possible because of a systematic approach, and you spend a lot of time in our guidance and our mentorship and doubt solving, problem solving classes and all of that. So even in the pro batches, you get all my lectures in the VBuddy format. Everything from chapter 1 to the chapter N, everything is there. So apart from me, obviously you have the best teachers in town, so that at the comfort of your home, you can get access to quality education with quality test papers, revisions, everything with syllabus completion on time. So do check it out. The link is there in the description box, right? So I hope you have enjoyed today's class, and smash that like button down there and have a great time, and see you in the next class where we are going to do more about accelerated motions for free fall. So we'll do free fall motion questions, and then we will go to non-uniform motion as well. All right. Bye bye. Have a great time. Take care.